My name is Alex Josh, and I'm a Director of Product Manager at Management, VMware Cloud and AWS product. Very happy to see you all here. Guess I don't have a clicker up here. All right, I'll do it the hard way. So today we're going to be talking about the stretched cluster feature of VMware Cloud and AWS, which is a feature that I've been working on for the past year or so. We will be talking about some things that are not quite in production yet, so just keep that in mind. I'll indicate which things are current and which things are future. Obviously, anything we talk about which is a future may or may not actually happen, but we'll do our best to be accurate and honest with you today. Just a quick setup for those of you that aren't familiar with the product. VMware Cloud and AWS was announced last year, so we've been in market for about a year now. And basically the top level story of what it is and what it's for is it's a SaaS version of vSphere, for lack of a better term. The idea is that we stand up for you a full SDDC, so that means native ESXi running on bare metal hardware, managed by vSphere, and it includes NSX and vSAN in the package. It's built by us, managed by us, operated by us, and delivered to you in a cost per hour basis. So it's a cloud style of experience, it's a SaaS style experience, but what you actually get is a fully running vSphere environment that works very similar to the way your on-premise vSphere works. This is not nested, this is not hosting. A lot of people get confused because they think that we're running nested inside of EC2. That's not correct, right? We're running on Metal as a service. So AWS has a product that they refer to as EBS Metal. The instance types that we run is called an i3.metal instance. So it's literally the world's fanciest ILO you've ever seen. We make an API call, they present a host, we present an EBS volume, it boots from the EBS volume, and you have native ESXi running on a bare metal host. What that means is that you have a system which is similar enough to on-premise, running the same bits, that you can do things like vMotion to cloud and back again. I'm not going to get into a lot of detail about the larger product. This is supposed to be a deep dive session. We have several sessions this week where we get into the generals about how this works. But the top level here is that because we're running vSphere on both sides, you can literally take a VM, vMotion it to cloud, right? You lose a couple of pings during the stun period, but the VM keeps running, right? That's not really something you can do on any other cloud. It runs in AWS's core data centers, which means that native services like RDS and things like that are available to you in a low latency layer 3 route. And so basically you're participating in the AWS environment, you're living inside that environment, but you're consuming vSphere natively, right? So when we say hybrid cloud, that's exactly what we mean. It's a hybrid between what AWS does natively and what we do in vSphere, running at the same time in the same place. The product is built, managed service by us. You buy it from us. You don't see a bill from AWS. The service is performed by us. If you have a problem, you open a ticket with us. If there's a problem with the underlying AWS infrastructure, again, you open a ticket with us. We take care of it. It's our problem. We own uptime. We own patching. We own the SLA. So that's the top level. But what we're going to talk about today is a little bit more specific. This is much more of a deep dive session. Almost a 300 level, so maybe 250 or so. We're not going to show you code, but it's going to be pretty detailed on how it works. And what we're going to talk about is availability. So one of the really interesting things that happens in the cloud is a lot of the restrictions and problems that you have on premise with availability and failures and restarts simply do not apply in the cloud because of the elastic nature of the environment. So we take advantage of the fact that we have this pool of hardware just ready to go all the time to react to situations. The multi-AZ feature, the stretch cluster feature itself, was actually designed to allow existing applications to run in a highly available multi-AZ mode with zero changes to the application, right? And this is very similar to the way vSphere works on premise, if you think about it. Your applications on premise don't really know what HA is, and they don't know what DRS is, and they don't have to know, right? Same thing here. The applications run in a VM, we make sure that the VM keeps running. Bad things happen in infrastructure, the VM keeps running. And that's the whole point, right? So it's that vSphere style experience is what you get here. So look, we're going to start with host failure remediation because that's the core feature, and then we'll work our way all the way up to a full AZ failure. But let's take a first step, right? So the first step is, well, what happens if I have a single host failure, right? what happens if one host has an issue? The first thing that happens is exactly like on-premise, vCenter notices that the host has a problem. Either we lost a disk, or we're having an ECC memory error, or the host is just completely unavailable, right? Whatever that is, VC is watching, and VC knows that this has happened. So we raise an alert, and we say, yeah, we think there's something wrong with this host. Unlike on-premise, the next step is not you go do it, fix it. That's not what happens. The next step is we go and we give you a new host. And the reason why we do that is because ESXi hosts in VMware Cloud and AWS are the classic pets versus cattle kind of thing, right? Your hosts on premise are pets. If something goes wrong with it, you fix it, right? These are not. These are cattle. If there's something wrong, you just shoot it and get another one, right? There's no point in fixing them because we have a theoretically unlimited supply of these. That's not really true, right? Turns out there is no cloud. There's just somebody else's operations team. But, you know, for all intents and purposes, if you need another host, you can get one. And so why would you ever fix a host? You just go get another one. And that's exactly what we do here. So what happens is we immediately provision a new host. And then because we're running vSAN, vSAN has replicas of all your data on at least 2 hosts. And so we rebuild the data that was on that missing host if the host is irrecoverable. So no data is lost. Right? Then we take the old host away and replace it with the new host. And what you wind up with is exactly the same running cluster that you had before. So something on premise, which would be a pretty severe, you know, P0 ticket where you have to go and get people to touch servers or do something, would just become a, oh darn, you know, looks like VMware is doing something. And so what we tend to say is we take your ticket from a P0 to a P2, right? So you know something has happened, you may choose to take a look, you might watch for a little bit, make sure you haven't had a performance impact, but ultimately it's a non-issue and it's solved. And this whole process takes about 10 minutes. So let's take a look at what this looks like. So in this case, what we've done is we've introduced a failure here. So you can see the highlighted host is red, right? So vCenter is notice that there's a problem, it's not responsive. So what's happening in the background is that vCenter is making a decision about whether the host is alive or dead, is trying to ping the host. And then eventually what happens is vCenter starts alarming, right? So you see this vSAN alarm that there's something wrong. In the background, all the VMs that we're running on this host are now being restarted, right? So HA, normal vSphere HA kicks in, and all the VMs have been evacuated already. So now your workloads are back up and running. And the question is, well, I'm down a host, what do I do about that? So you'll see here that there's this new property called add remediation in progress true. So what we do is to let you, the operator, know what's going on, we set this custom property to true to let you know that there's a background operation going on. And if you look in the UI, you can see, hey, we're provisioning a new host, right? And that takes about 5 minutes. So I've sped this video up, and this is why I'm not doing it live. And then eventually you'll see in the yellow there, the host shows up, right? And it starts to be provisioned. So down at the bottom you see a whole bunch of provisioning operations happening. We're adding it to the vSAN cluster and we're capturing the disks. And then what'll happen is it'll join the cluster, it'll go into maintenance mode. Well, it'll join the cluster in maintenance mode, of course. Once all of the remediation is done, then we'll take it out of maintenance mode, add it to the cluster, right? And then your capacity is back. So now you see that the host has been added to the cluster. It's still in maintenance mode. And you can see down at the bottom here, there's a whole bunch of vSAN operations happening. So the total span that we're talking about from the initial failure to completely done is about 15 minutes, right? So there is definitely a period where you're running at less capacity, right, than you want to, but it's not so long that you really have to worry about taking any other remedial action. The assumption here is you're going to be running relatively hot in these clusters. You're probably going to be running 80–90% of capacity. But even in our system, you probably don't want to run 100%. Right? Because one outage, you want to be able to survive one physical outage, right? And so over time, what happens is all of this work happens, you join this cluster, and then now that you see it's taken out of maintenance mode, and now DRS kicks in, and it's going to rebalance the cluster and vMotion VMs back onto the new host. So, so basically what's happened now is that the failed host is still there in the cluster, and once we decide that that host is not recoverable, we'll remove the host from the cluster, and you'll be back to where you were before, right? So that's kind of the sequence of events. Make sense? Yeah? Okay. So that's the basic feature. We've had this feature in the product since day one. We've done, you know, a couple of thousand host remediations over the past year. We're managing a very, very, very large fleet, probably more hosts than any of you have in your environment. This is all automated. This is a very well-trodden path. It works great. The reason why this works is because of the underlying vSAN architecture. So I'll spend a little time talking about vSAN and the way you control vSAN. So vSAN is one of those things, by the way, just to be perfectly honest, I stole all these slides from a gentleman named Glenn Sizemore. So if you run into Glenn Sizemore, tell him thanks for me. And Glenn, if you're listening, thanks a lot. Just want to be honest about where these slides came from. Glenn has very carefully pointed out exactly the way the system works under the covers with some really nice screenshots here. This is all live and in production, but we thought some pictures would help it to be easier understood. So that's why we're doing it this way. So when you interact with vSAN, it turns out that the way you interact with vSAN is through a feature that we refer to as Storage Policy-Based Management, or SPBM. And it's a little deceptive because it's very easy to use. So it's sometimes not obvious all the really complicated stuff that's going on underneath, right? We tried to keep the UI very, very simple to consume and easy to use. So SPBM is designed to allow you to set a storage policy, and that storage policy can then be set on a per object basis inside of vSAN. And when I say object, what I mean is anything that we store, right? So that could be the configuration files for the VM, it could be a VMDK, right, any object. So for example, I could have a database server that has 3 hard drives. One of them is a log drive and I set to RAID 1, and one is a capacity drive that I set to RAID 5. In vSAN world, that's perfectly fine, right? So unlike a traditional storage array where storage policies are set at the LUN level, right, or the data store level, in vSAN world, it's actually set on a per object basis, and every object can have a slightly different policy. And I don't think that's really well understood, because people will say, oh, I have vSAN set to RAID 5. I'm like, well, what does that mean? You mean like all your VMs are set to RAID 5? Well, vSAN's set to RAID 5. Like, I don't know what that means, right? You don't set vSAN to anything. This object, right, this VM, this hard drive is set to which policy? Now, if you use the product, you'll see that there's a default policy. And so probably what they mean is that their default policy is set to RAID 1 or RAID 5. But that's not really the way the product is designed. The way it's designed is that you should set different levels, right, for different levels of capacity versus performance, and then apply that to VMs when you create them. That way you can have this very, very high performance or very, very low capacity and this breadth of offerings within the same data store, right? So it's much more efficient that way, and then you give the VM just what it needs. You don't have to run everybody at RAID 1, but then again, you don't have to pay the penalty for RAID 5 when you don't need it. Anyway, so how do I do that? Well, I do that by creating policies in SPBM. So what you'll see here is I have the simplest policy, which is nothing, right? So I can actually tell vSAN that this VM is ephemeral, and I don't want to have backup, and I don't want to have high availability, and I just want the most efficient, cheapest storage I can get, because this VM is ephemeral, and if it dies, I'm going to rebuild it. Okay, fine. So you create an SPBM policy, and you say followers to tolerate none, and you say RAID policy is none, and now what happens is when you write the disk, it goes onto one physical device, and only that one physical device is not replicated anywhere. Very, very efficient, but no availability. And for an ephemeral front-end server that's just running a couple of containers, maybe that's the right thing, right? Because all you're going to do is kill it and spawn another one later, so why bother backing it up and why bother recovering it? On the other hand, you may want to have the ability to set RAID 1 mirroring. So if you set RAID 1 mirroring, what happens is that exact same object we created before is still there, but now we have a copy of that object. So notice that we're now taking up 2x the storage, right? Because I have the data copied twice. And then you notice that little W there, that stands for witness, right? So for every object, you have to achieve quorum. And the reason why that's super important is you don't want to have 2 different hosts thinking that they have the authoritative copy of the data. So how do you resolve that? It's through the witness. So you have to, once you achieve quorum, then you can decide who's the authoritative owner of this data. If somebody goes down, then they talk to the witness to decide who has quorum, like if you have a split brain, right? So if host number 4 just suddenly lost its connection to the other 3, he would say, oh wait, I can't see the witness, so I'm not authoritative, so I'm not going to accept rights to this object. But if hosts 2 and 3 survive, they can talk to each other and they say, yep, we have quorum, because I own the object, I can talk to the witness, we have quorum, we're the surviving pair, right? That way you don't get data corruption. So if you keep going, right, now you can change the level to, say, RAID 5, right? So what happens if I do that? So then what happens is we take the data and now we stripe it, right? Everybody knows what RAID 5 is, right? Striping with parity. So what we do is we stripe now across these 3 hosts and we write a parity bit to the 4th one. So one of the things you're going to notice in VMC is that because we now allow you to have smaller cluster sizes, some of these features are not going to be available to you at certain cluster sizes. So for example, we announced this week that we were supporting a 3-node cluster in VMC, which is great because it's cheaper, right? It's 25% less as a starting point. But what that means though is that you can't run RAID 5 policies in that cluster. Why? Well, because of this, right? We need 3 stripes and we need a parity bit. 4 host minimum. So that, if you go try to create that policy in a 3-node cluster, you'll get an error and it says, sorry, you don't have enough hosts. So if you need to do RAID 5, go to 4 hosts. And by the way, this is one of the reasons why we supported 4 host minimum in the original product, is because we wanted to make sure features like RAID 5 worked, right? Because RAID 1 is it's 2x the data, it's not super efficient. So most customers in production are running RAID 5, and so you need 4 host minimum vSAN to do that. Make sense? Of course, this goes on, right? You can keep going. So then you go to RAID 6, right? But in RAID 6, you need more hosts, right? So now RAID 6 has 2 parity bits. So now so see how this is going, right? So now we can accept up to 2 failures, right? We can lose 2 complete hosts and still survive because we're writing the parity bits in 2 different places. So as your cluster gets larger, right, you can actually support higher levels of failure. And in fact, if you have a very large cluster, 16, 18, 19 nodes, you're definitely going to want to have failures to tolerate set to 2. Because if you think about it, if you do the math, your odds of having 2 failures, if you have 16 nodes, is twice as high as if you have 8 nodes. Yeah? You're all with me on that? It's math. If I have a failure once every 10,000 hours, I have 1 host. I have 10,000 hours, I have 1. If I have 16, I'm going to have 16 failures. Right? Make sense? So your error rate is based on the size of your cluster. The larger the cluster, the more odds you're going to have 2 failures. Therefore, you want to have higher levels of protection. So there is kind of this over-under, at which point making the clusters bigger and bigger and bigger may not be your best strategy, right? So people always ask me, say, well, how big of a cluster can I make in VMC? And the answer is 32 nodes, but please don't do that. You're like, well, wait a minute. Do you support it or you don't support it? Like, yes, we support it. Factual. However, I want you to think very carefully about why you want 32 hosts in a single cluster. Keeping in mind that now we've just gone to very much more likely to have multiple failures in an outage window. Why wouldn't you just have 2 16-node clusters? Right? Now your odds of having 2 failures in the same cluster at the same time are half as common as if you have 32 nodes in one cluster. You with me so far? Okay. So what we did is we allowed you to create up to 10 clusters of 32 nodes each. So in theory, 320 hosts. But probably your realistic best practice, just based on math, is probably to go with 16 times 10, 160 hosts. If you need more than 160 hosts in a single SDDC, please come see me after the break. I have a gift for you. That was a joke, folks. Okay. I do have a gift for you, but that's a lot of hosts, right? So if you get to that point, there's other strategies we can employ, right? We can add more clusters, things like that. So as a starter set, 160 seems like a pretty reasonable number. Does anybody have more than 160 hosts in a single VC running in production right now? Yeah, okay. So we're pretty good. When you do this, it's super important to understand that the SPBM policy, although you can change it at any time, it's not free. There's no free lunch here. There's still data gravity to deal with. So what I mean by that is, let's say I create a 16-node cluster, right? So that gives you, in effect, 160 T of usable storage, right? And so I start filling that up at RAID 1, boom, 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 boom. And I get 300, 400, 500 VMs in there. I've got 50 terabytes in there. And then I say, yeah, you know what? I really want RAID 5. Can we just change that to RAID 5? Yeah, you can. But keep in mind that you're going to have to do this translation from 2 objects to 5 objects for 20, 30, 40 terabytes of data. So that operation ain't free. And so you're going to want to think very carefully when you change SPBM policies against an object, how many objects are you changing at once, right? Strongly suggest you do them in batches, 10, 15, 20 at a time. And what is the net effect of that change on the storage subsystem? Because you're going to generate a lot of read and write traffic when you do that. So if you're running at 70% of capacity and you suddenly tell the system to rewrite every single object that it knows, you should expect to see a non-trivial performance impact on the system. So you're going to want to think that through and kind of plan that carefully. What we strongly suggest is that if you have a regular old workload that has no special requirements, there's nothing amazing about it, that you start with RAID 5, FTT1, right? That's a good default. And then if you need to, then you can go on from there, right? Because that's kind of the best balance between complexity and cost. If you're going to go to a large cluster, right, 6 nodes or more, then I would probably suggest you start with RAID 6 because it's a little bit more efficient, right? But these are just best practices. You can do what you want. But just keep in mind that making changes, although it's possible, it's not free. So think it through, plan in advance. If you need help, we're always available to you on chat, right? So one of the great things about VMC is on every single screen, there's a little chat window in the corner, right? You click on the chat window, boom, you're going to be talking to us, one of us right away. So if you have questions, you're not sure what to do, you're like, hey, I made a mistake, I set everything to RAID 1, I really want RAID 5, what do you think? We're happy to talk, right? We have nothing better to do with our time. In fact, that's literally true. There's nothing that we can do with our time better than speaking to customers. We're always happy to. So that's what's going on with availability and auto remediation. So if you think about those 2 basic features, and then you layer on top of it now multi-AZs. So what we did is we took the existing vSAN product, and it already had this feature that they refer to as stretch cluster. And it's designed for metro clustering on premise. And so what we did was, we said, well, what we'll do is we'll take a vSAN cluster, we'll stretch it across 2 AZs, and we'll align the underlying vSAN fault domains to those 2 AZs. And what that allows us to do is it allows us to take a single VM and have synchronous replicas written across 2 AZs. Now, if you're an AWS customer, what you'll know is that AWS strongly recommends that any production app you run in AWS run in at least 2 AZs. Because they don't guarantee AZ availability, they guarantee regional availability. Right? They say the region's going to run, and at least one of the AZs are going to survive. And so the way you have high uptime is by having multi-AZ. And you say, great, that's fantastic. How do I make my app native AZ? And they say, well, what you do, step 1 is you rewrite your app, okay? And then you make your app aware of, whoa, stop. I can't rewrite my app. Oh, I'm sorry, well, we can't really help you. I've got this COTS thing that I bought for some vendor, and the vendor's out of business, and we can't, it's like, you're out of luck, right? So what we do is we take the opposite approach, and we say, look, our business is to run VMs regardless if they know what's going on, right? So we take that exact same premise and we say, well, we're just going to apply that exact same thing to VMC. And so when a VM is running in AZ1 or AZ2, it's our problem to worry about whether the AZ is alive, and it's our problem to make sure that the data is replicated, and it's our problem to worry about who's the winner and race conditions, and those are all our problems, and we have to worry about that. So if you have a random piece of software that you bought from somebody else or something that was developed a long time ago, or you're simply unwilling or uninterested in replatforming it, you would just drop it in here and you would gain multi-AZ availability without doing anything, right? So there's some complexity here. So when we lose an AZ, so first of all, there's not like a big red light that goes on in AWS that says, hey, we lost an AZ. That's not what happens. So you can't actually look in the logs and say, hey, when did we lose AZ1? That's not actually the symptom that you see. What actually happens is all of the objects in that AZ go offline. That's how you know. So in our case, what that means is that we have to create an artificial barrier inside the cluster so that half the hosts are on one side of that artificial barrier and half the hosts on the other side of that barrier. And we refer to that as a fault domain. And so we align the hosts with the AZ1 in fault domain 1 and AZ2 in fault domain 2. And so if every single host in fault domain 1 goes away, we're fine, right? We can survive that. But in order to figure this out, because by the way, there's been a lot of AZ outages in AWS land. There haven't been like the big smoking hole outages that we all think about. It's much more common to see like a cable cut or loss of connectivity, right? Those are things that are relatively common. And I'm sure that happens in your own data center as well. I mean, actually considering how big their data centers are, it's pretty amazing the level of uptime you see within AWS, but nobody's perfect, and even within AWS, we have seen some outages. The most common thing is that AZ simply goes offline for a period of time and then comes back. That's the most common thing. And in lots of cases, the hosts within that AZ think everything's fine because they're still running and they can talk to each other, but they can't get out, right? It's a connectivity loss. So what we do is we create a third-party witness VM, and that third-party witness is actually running a third AZ. So there's really 3 AZs involved in this transaction. There's a workload AZ1, workload AZ2, and then a third witness only. And that witness is actually just running in a VM, so it's not a really big machine, and his only job is to direct traffic. So in this case, AZ1 has lost connectivity. Let's pretend like those hosts are still running. So they think that they're fine, but they can't talk to the witness. The guys in AZ2, they can talk to the witness. Well, 2 votes to 1, they win. These guys now take over. So now all objects in the cluster are now owned by the hosts in AZ2 only. At this point, just like the demo I showed you before, vSphere HA kicks in, right? What does vSphere HA do? Restarts the VMs. Where? On the hosts that are authoritative for the object. So basically what's happening is the existing HA subsystem works unmolested and restarts all the VMs in AZ2. So yes, we just survived an AZ outage, but really what happened is that we had multiple hosts going offline at once, right? We don't actually have an event in vSphere called AZ outage, right? The event is these hosts are not there, the VMs that we're running there get restarted, and it's exactly the same code path that you've run on premise for many, many, many years. Hopefully you're all running DRS and HA on-prem, hopefully. And that feature that you've been running on-prem for the past, 5, 8 years now, a long time, is exactly the same features we're using here. There's some enhancements, but it's the same basic code path. The other interesting thing is that our path outbound to the internet and to your corporate network and all that stuff is actually via a VM, right? So again, if you haven't seen VMware Cloud and AWS before, there's some detail there you may not be aware of, but what we do is we actually use NSX edge devices running in VMs inside of VMC, and that's our path out to the internet. Well, so what happens if you have your outbound connectivity in AZ1 and AZ1 goes offline? Well, we already talked about this, right? The VMs get restarted. So what happens is your gateways automatically restart in AZ2. Now you could have an outage at this point, right? Because route propagation, DNS propagation, et cetera. So there could be a couple of minutes where you can't talk to the outside world because you just lost your route. And now we have to do a route propagation outbound and let everybody know, hey, we're not here anymore, we're over here. But considering that we lost an entire data center, not too shabby, right? So, but to be clear, we're not talking about no downtime, right? Somebody once said, hey, you'll never lose a ping. That's not true. You will lose some pings, right? But the point is the system will come back. You'll have no data loss, right? Because your data loss is 0. And connectivity will drop until we restart and reestablish and repropagate the routes, and then connectivity will come back. So that's the thing. So it becomes yes, it's an outage, but no, it's not fatal kind of event. We really consider this to be a high availability solution. We really don't consider it to be DR, right? So there's kind of this discussion. It's like, well, hey, Alex, if I'm using a stretched cluster, do I really need to do DR anymore? It's like, I don't know, right? What are you trying to protect against? Are you trying to protect against, some numbnut, like unplugging a Tor? Then, yeah, you're good. Are you trying to protect against a tsunami hitting Portland? No, right? If Portland goes, all these data centers in Portland are all going to go together, right? If there's, well, up there, I guess it'd be more like a volcano, right, or an earthquake. But if something is severe enough to take out all of Portland, this isn't going to help you. So you have to ask yourself what kind of negative event you're trying to protect against. If it's simply a equipment failure or a rack failure or a very severe data center outage, power, things like that, then this is probably sufficient. But if you have a requirement in your business to survive a tsunami level event, then no, right? What you want to do is you want to do this and DR, and you want to DR, please, to another state at a minimum, right? So in our case, we operate in Oregon and Virginia. So you have a primary in Oregon and your DR would be Virginia, right? If you really wanted to be, tick all the boxes and be really, really secure. So let's look at the way this actually works, the way you configure this. So what happens is when you create an SDDC, we ask you a question, which is a very innocuous question actually, is do you want to run a stretched cluster or a non-stretched cluster? Now, for those of you who have ever set up a metro cluster type environment, you'll realize how much easier this is than doing this in the physical world, right? And to be clear, we're cheating, right? We're cheating because we're using all virtualized infrastructure. We're using an SDN, right? So we're cheating like crazy. But if you try to do this on premise, this is quite difficult, right? I've worked on, my background is enterprise IT operations, and I've set up lots and lots of stretch clusters over the years. And the difficulty involved goes from absurdly complicated, right, like creating your own circuits from scratch, all the way up to mildly, annoyingly complicated, pulling dark fiber, So it's quite difficult to do this on-prem. In our case, it's check a checkbox. And so what happens under the covers is that we automatically deploy your hosts into the AZs that you tell us to deploy to. We then build an overlay network on top of that using NSX, and we connect the two groups of hosts into a single unified cluster. And as I mentioned before, vSAN ensures that we have objects replicated across that boundary. NSX makes sure that we have common L2 segments across that boundary. Now the reason why this works is because AWS regions are very tightly coupled. So the latency from US West 2A to US West 2B is ridiculously low, right? Like a millisecond or less, because they're across the street from each other. They are separate data centers, but they're in the same physical locale. Hence my comment about the tsunami, right? They're not, in another state, they're really close. And so speed of light helps you. And of course, our friends in AWS have these massive honking pipes, which is really cool. And so the throughput and connectivity is pretty good. So you can get away with these permanent stretched L2s from AZ1 to AZ2 because that's what they were designed to do, right? And so once you do this and you provision it, then you get the running SDDC. Once you've done that, the user experience is basically at that point is exactly the same as you would normally expect. And in fact, if you don't pay close attention, you may be unaware of the fact that you're running a stretched cluster. The big giveaway is that when you go into vSAN and you create your SPBM policies, you'll see this new option here. And the option is site disaster tolerance. So let's say that I don't want to have any site disaster tolerance. Let's say that I want this VM to run only in site 1 and not in site 2. Well, surprise, surprise, nothing changes. It's exactly the same picture we had before, right? So we have this RAID 5, we have these stripes, we have a parity bit, done, nothing changes. So if I have workloads that are not important to me, like dev test workloads, and I don't want to waste the storage space to have them copied on both sides, well, I just turn site-to-site replication off. Now if I do that, what happens if I lose AZ1? Well, those VMs are no longer available. Okay, because that's what you told us to do. You told us not to copy the VMs, so they're not there. If it's a non-production workload, it's a dev test thing, maybe that's totally fine. And or if it's a ephemeral VM, that's totally cool. However, what you probably want to do is you probably want to change that to dual site. So once I make this change, again, keep in mind that if I change like 1,000 VMs all at once, I have to copy all 1,000 VMs across, so please make these changes thinking this through. But when you do that, what happens is we just copy everything that I just talked about over into the other AZ. Notice that I've mirrored in this case, right? So I'm doing RAID 1 this way and RAID 5 inside the AZ. So I've actually have multiple redundant copies. So if I take a single host outage in AZ1, I actually rebuild the bits from the local copy. I don't have to go to the far side. If I lose the entire site, now I have an additional copy, but you'll see that it's a redundant copy. So if I lose AZ1, and then an hour later, I lose host 2 in AZ2, still protected, right? Because I have redundant copies. So this is kind of the belts and suspenders approach, right? So this VM is very safe. Depending on your level of sensitivity, you may or may not want to use that setting for every VM, right? So do it appropriately based on your business requirements. You'll also notice that this witness component gets created here, as we discussed before. That's for split brain, and that allows it to do that. So we just take metadata about that object, and we push the metadata only over into this third AZ. And his only job is to mediate if there's some confusion about who owns the object. The side effect here is that we're copying a pretty large amount of data from AZ1 to AZ2, as you can imagine. And the amount of data that we copy is actually 1.2 times the write volume of the VM. So what I mean by that is, let's say I write 1 terabyte of data into my VMDK. I'm going to transfer 1.2 terabytes across this AZ barrier. So keep that in mind. That transfer is charged, right? There's a transfer charge, 1 penny per gigabyte. So it's not free, right? But it does allow you to recover, and it does allow you to have a very high availability. And so this is why I keep bringing up the notion that says, make sure that you apply your business policy correctly to the objects that you need them, right? You may not want to have every object replicated on both sides. You take up storage that way that you need to do. You're also paying a replication fee. So just keep that in mind. You don't have to replicate the objects if you don't need to. The other thing that happens is that in DRS, by default, we will place a object, a VM, on any host in the cluster, right? So we'll just pick it up and move it, and pretty much whenever we feel like it. And in a cluster within a single AZ, that's exactly what you want us to do, because all the hosts are effectively the same. However, what happens if you have a client-server application where you have 2 VMs that are really screaming at each other? You probably don't want us to just randomly pick up one half of the client-server app and move it to the far side of the AZ barrier, right? That's probably not what you want us to do. So what we've done is we've made, sorry, this is the picture of what you don't want us to do, right? So this is what would have happened before. And so what we've done is we've made some changes, and we've made DRS fault domain aware. Now to be clear, DRS is not aware of your AZs, but it doesn't have to be. What it does is it looks at vSAN, and vSAN has 2 fault domains in this case. And DRS says, okay, this VM is in fault domain 1. So if it's in fault domain 1 and I need to move it, I'm going to move it to another host still in fault domain 1. And so we call this sticky DRS. Basically what it means is that DRS is aware of and honors the boundaries between these 2 environments. And it does, quote unquote, the right thing, right? What you would expect it to do. It keeps it there. The way that you tell us that you want VM1 in AZ1 is by provisioning it there, right? So if you manually provision a VM in AZ1, it will stay there. If you manually vMotion it to AZ2, it will stay there, right? So your manual override actions is the winner. We won't automatically move it out of that AZ. Unless there's an HA event, right? So if we have to restart the VM, then and only then, we'll move it to the far side. Hopefully that's what you want us to do, because that's the way the product works. And if you think about it, it makes sense, because during an HA event, all bets are off, right? And it's about making sure we get the workload back up, and where it's placed is probably less important to you at that moment than just getting it back up and running. So we restart the VM, we do the right thing. Later, the most likely outcome of an AZ failure, by the way, is that the AZ comes back 2 hours later, 3 hours later, a day later. And so in that case, what we actually do is we still have the data on both sides, and we resync the data, right? So there'll be this period where the side that was down is out of date, and you'll see, if you look at the vSAN details, you'll see that there's a lot of objects that are imbalanced, and then slowly what we'll do is we'll bring them back in balance, right? Depending on how long it's been out. So anywhere from an hour to a day later, you'll see vSAN retrieve its equilibrium, and at that point, it's safe to basically repatriate the VMs to the far side if you need or want to do that. Sorry, the question is? The question is, do we automatically move the VMs back and repatriate them back? No, we do not. In no case will we ever move a VM from AZ1 to AZ2 unless it's a terminal event. If the choice is not run the VM at all, then we move it. So after a terminal event, you have all your VMs running in AZ1 and you want to move some back, you have to do that, right? We don't want to take that action. The other reason why we don't is because if you have flapping, right, we could move them back and then lose the AZ again. So there's some human judgment involved, and you say, yeah, looks like it's been up for an hour or a day or whatever. It seems safe, let's fail back. You always want a human in that. It's exactly the same reason, by the way, that SRM has the manual failover now button, right? Because it turns out that building machine rules that can figure out when the thing is really failed, or worse, when it's really unfailed, and it's safe to go back, that's a human judgment decision. And so we intentionally didn't make it auto fail back. You have to go in and do it. I mean, keep in mind that during this entire time, your VMs are still running. They're just running over here instead of where they were originally. Other questions? Yes, sir. I think the question is, hey, there's no redundancy in witness. What's up with that? So pretty much summarizes it. So there's no redundancy in the witness because you don't need redundancy in the witness. There's no, oops, wrong picture, there you go. So this witness object is just metadata. So if you lose the witness, what you would do is you would throw it away and start over again, and then you recalculate all the metadata. Because remember that the witness data is simply a copy of the data from the two running hosts. So we can survive a loss of any one AZ, including the third one. If we lose the third one, our response is to rebuild. If we lose the first or second one, our response is to HA restart. So we treat a witness loss exactly the way we treat any other host loss. Replace and rebuild. And all that data can be recalculated. Now, if you lost the witness node, and then 30 seconds later you lost AZ1, well, now all your data is down, right? And we'd have to do a manual rebuild. But we're not trying to protect against dual AZ failure. You know, our commitment to you is to protect against single AZ failure. And those events are pretty rare, so we think that's a good compromise. Otherwise, you have to have yet another third copy, right? And that's super expensive. Yes, sir?
Is that AZ in Oregon?
All three AZs have to be in the same region. Sorry, the question was, is that AZ in Oregon? Answer is it has to be in the same region. And therefore, this feature only works in regions that have 3 AZs, 3 or more. And now in our case, all of the regions where we operate in AWS land all have 3 AZs. And so we will always provision the witness to a third AZ within the same region. In theory, you could put the witness further away, but that makes the networking and stuff much more complicated. You don't want, by the way, the two compute AZs to be too far apart because we're doing fully synchronous write commits. And so you want to have very, very low latency there. So you certainly wouldn't want to have AZ1 in California and AZ2 in Virginia, right? That simply wouldn't work because of speed of light issues. It's exactly the same reason why a lot of metro cluster solutions out there have a 100-kilometer limit, right? It's simply speed of light, right? You don't want that much latency in your write path. And it's the same for us. Okay. So there are some caveats here that I want to make you aware of. The configuration of multi-AZ is a deployment time option only. So when you create the SDDC, you tell us to make it a stretched or not stretched. You cannot change that later. There's no upgrade to stretch. There's no downgrade to single, right? It's a one-way trip at provision time only, cannot be changed. And the reason is because when we lay out the networking, we do it in a very different manner. And changing that is very expensive. So if you want to use this feature, you need to make that decision when you deploy your SDDC. At the moment, we only support a single cluster in the stretch. We are working on multi-cluster, and we'll be doing that shortly. But at the moment, you can only have up to 1 cluster. The networking costs between the 2 AZs, as I mentioned, we do bill that through. Now, the bill doesn't come from AWS, it comes from us, but still it appears on your VMware bill. When we egress the network, we egress only from one side or the other, not both simultaneously. So you could have some corner cases where you trombone data back again, right? So let's say you're going from, you're on the AZ2 and your egress is on AZ1 and you're trying to open up a network connection to your on-prem data center. So it'll transit across the AZ barrier first, and then out and down to the DX. So you need to be aware of that. If you have workloads that are using the WAN very, very heavily, or using the internet very heavily, you may want to affine them to the AZ that has the CGW, right? The egress point. So you may want to keep the VMs on the same AZ as the egress point, so you're not paying for that transit and then going out. It'll still work, but it may be not optimal from a cost and performance perspective. And then you choose 2 AZs, and we pick the third. So you don't have any control over where the witness runs, but you do control where the compute is. So if you have, workload in, US East 2A or something like that, you want to make sure we're in 2A, you put us there. The witness runs in a third, and we worry about where that runs. Okay. Any other questions before we go on? Yes, sir. In the current implementation, it's 1 cluster per SDDC. Multi-cluster for SDDC is coming. You can have as many SDDCs in an org as you wish. Okay. So that's the kind of end of the prepared material I have. I'm happy to talk about other things. Super important to note here, if you didn't see in the general session, we've got a pretty good promotion here. I'm not usually the sales guy, but I'll do my best. So what we've announced is that we're doing 20% off for a single host SDDC. Now keep in mind that single host SDDCs don't have an SLA, we don't patch them, we don't maintain them, but they're really good for kicking the tires and doing dev tests. And if you just want to try it out, that's your easiest path forward. Those SDDCs are time bombed though to 30 days, right? You can only run them for 30 days. And at the end of that 30 days, either you upgrade to a 3-node SDDC or you have to terminate the SDDC. And those are your only 2 options, so do be aware of that. And then the other one is that if you do buy a 3-node SDDC, we'll discount it down and we'll only charge you for 2 hosts, right? So in effect, you're getting 3 hosts for the price of 2. So doing the math, that's a 33% discount. That's a pretty good deal. And the reason why we're doing that is because a lot of customers say, well, I only need 2 hosts right now. Can I have a 2-host SDDC? And as we saw in this conversation, 2-host SDDCs are kind of problematic. So we're like, look, we'll give you a 3-host SDDC, but we'll only charge you for 2, just to kind of make the gap. So that way there's a clean progression from 1 to 2 to 3 to 4, et cetera, right? Over time, we'll probably wind up with smaller SDDCs, but at the moment, 3-node is the smallest one that we support. Okay, so thank you very much for your kind attention today. I very much appreciate it. Please do fill out your survey. We take your feedback very, very seriously, and enjoy the rest of the show. And I'm happy to take questions. So, any questions? Happy to take them. Yes, sir, in the back. I can barely hear you. You want to come up to the microphone or just speak up a little bit?
I thought there was a 4-host minimum for your SDC, not especially you had to add 1.
Yeah, so the question was, hey, wait, I thought there was 4-host minimum. What's up with this? The answer is, yesterday we announced that the minimum was dropped to 3. So that you were absolutely correct until yesterday. It just changed. Always until yesterday. That's always the way it goes. Yes, sir. I think we had another question up here. Yes, sir. Yes. Yeah, so the question is, well, I've got an Oracle application that relies on NFS. And so the answer is that depending on where you mount the NFS from, so let's say you put it in a VM, in a VPC or something like that. Yeah, so if the NFS VM is in VMC, then we'll make sure that that is still running, and this will just keep working, right? Question, network disruptions. No, but the VM itself might terminate and reboot, right? So if I'm running on host 1 goes away, well, now he's shut down, right? So we'll restart him, but there'll be an outage there while we do the restart. Unless you're running some sort of product that allows you to do active-active, right, in the guest, in which case you would run one on one side and one on the other. Or if we used a product from our friends at NetApp or something like that, right, we have a clustered file system. But if you have just one VM and it's running on AZ1 and AZ1 goes away, then what would happen is you'd see it drop. We would restart the VM on the far side, and 3, 4, 5 minutes later, however long it takes the VM to reboot, it would come back. Just like a normal HA event, right? Yeah, so if you have an app that's super sensitive to that, you may want to go with a clustered file system that has 2 nodes instead of 1, and you put 1 node on AZ1 and 1 node on AZ2, right? That might be a better solution in that case. Yeah. Yes, sir.
You sharing best practices around, I think it's great, the connectivity back to your corporate data center, just VPN today, is that correct?
Yeah, so the question is, what about connectivity back home? So we do support DX today, and for most of my customers, that's what they want for production workloads. So we support IPsec-based VPN or DX. If you talk about best practices, we support both, but yeah, most of my customers, when they go to full production workloads, they're moving towards DX. So that's probably where my head would go, unless it's something that's a very rarely used or a non-production workload, like a dev test sandbox or something like that. But if you're running like a production database, mission critical, I'm probably going to go DX, and I'm probably going to go with 2 DX circuits, right, for redundancy. Hopefully that's not a big surprise to you. It's probably the same advice you got from our friends at AWS as well, hopefully. And then then your connectivity is based on your provider. So normally you drop that into your MPLS cloud, and MPLS clouds are highly redundant. And assuming that your endpoints survive, your odds of taking a network outage are relatively low. In VMware's case, that's exactly what we do. We have a production data center in Washington State. We have 2 10 gig circuits that we drop into PDX, into the Portland data center, Oregon region. And then we run parallel private VIFs using DX. And that's the way we run in production. Yeah. Okay. Yes, sir. Question, what is the minimum vSphere version? It turns out that we manage the vSphere environment. So everybody in VMC runs exactly the same vSphere version, which is an advanced build beyond 6.7. So you can't control that. Everybody gets the same version. If there's a patch, we push the patch out globally. You're not allowed to opt out of patches. For example, we just had an emergency security breach, not a breach, a security vulnerability, right, from Intel a few weeks back. I don't know if you're sure you heard about that. We pushed our patch within 48 hours, right? So the good news is that patch management is something that we take care of, and it's always done. It's probably going to be done faster, and you can do it on premise. The bad news is you can't say, hey, I want VMC running 5.5, right? We can't do that. If you think about the velocity that we operate at, the only reason we can get away with that is because we only support 1 version at a time. So when we do testing, we don't have to test back versions. We don't have to say, oh, what happens if we have an ESXi 5.5 host and a vCenter 6.5 thing? On-prem, that's perfectly legal, but in VMC, we don't do that. So we have a much more rapid iteration cycle, and the way we get away with that is we have a much smaller testing surface. So it's one of those give-get scenarios. So you have to decide, are you willing to give up control over the exact version of vSphere you run and the patches we run? And in turn, what you get from us is service and support. And frankly, it's our neck now on the line if VC has a problem. We fix it, you don't fix it, right? If there's an outage or something like that, that's our outage, that's our problem. The SLA belongs to us. If there's financial penalties because of that, there are financial penalties. So there's just kind of a business relationship difference that you have with us in VMC than you have when you buy a product. And that's not always right for everybody, right? I mean, some people are like, no, I have this very specific version of vSphere, I have to run it, and that's the only version of vSphere I can support. In that case, probably VMC is not for you, right? Because that's just not an option for us. On the other hand, if you're like, look, I don't want to be in the business of managing patches, I want to be in the business of managing hosts, I just want to get capacity, then VMC is probably more appropriate for you. Yes, sir. Yeah. So the comment is that the CGW seems like a single point of failure, and it seems like a single choke point. So right now we're running a pretty large CGW, and we monitor this pretty carefully, as you can imagine. All of this architecture changes in the NSXT timeframe anyway, right? So we go to this kind of multi-layered router approach instead of a CGW approach. So my first answer is there's actually 2 CGWs. They operate in pairs, so it's not a single point of failure, right? So it's an active standby. If one of them fails, we switch over to the other one. So we don't have a single point of failure there. Yes, in theory, that becomes a bandwidth limiter. But at the moment, we're actually running at line speed, and we're not seeing it. We have options to make those objects bigger if we need to do so, but we haven't done that. And then in an NSXT world, that whole architecture goes away anyway and gets replaced with the new NSXT routing architecture. So that's kind of the long-term path is to NSXT and away from NSXV style edge devices. Yeah. I would definitely encourage you, if you're interested, to nail up an SDDC and try to break it. That'd be fantastic. Love to hear how successful you are with that. And if you find limits and stuff like that, then we'll go after them. The other thing is if you're ever in the platform and you're running a test, especially if you're doing like some sort of penetration test, please do let us know, because we do have very tight monitoring and we may turn you off, right? So we had a customer that was doing a black hat penetration test and he lit all our alarms and we shut him down, right? Which is exactly what you want to do when you have somebody, you detect someone doing trying to penetrate all your interfaces. That's probably not what he wanted us to do. So what we do is, when you're doing testing like that, if you just open a ticket and say, hey, by the way, I'm about to do this destructive test, and then we'll say, okay, thank you very much, we'll turn your monitors off, have at it, and then we'll say, hey, how did it go, and how far did you get before you got it to destruction, right? And that's the way we do that. I think I have time for one more question. Yes, sir.
Is there any solution to helping do DR in the VMware Cloud, like asynchronous?
Yeah, so the question is, what about DR? We talk about HA, which is synchronous. What about DR, which is async? Yeah, so built into the product is what we refer to as site recovery. So site recovery is basically SRM as a service. And so if you've ever used SRM, it'll look and smell very similar. The difference is instead of array side replication, we use vSphere replication because there's no arrays in VMC. And so what you can do is you can do asynchronous replication from whatever, from Oregon to Virginia, or from Oregon to your on-prem, or from on-prem to Oregon, whatever, up, down, left, right, doesn't matter. And then the minimum RPO that supports is 5 minutes, however. So this is 0 RPO, and then you can have a variable RPO to a foreign site. So the lower you turn that knob, the more performance penalty you pay, right? And the more bits you traverse. So most people will set the offsite backup to like a 1 hour RPO, and then they run a 0 RPO within the region. That seems to be the common pattern there, but that's under your control, right? It's also very common for us to actually be the DR target. A lot of customers say, well, I'm going to keep my production data center, but I've got this tertiary DR site over here that is not staffed, and I have to patch and I have to maintain, and I rotate hardware through there every couple of years, and it's a pain in the butt. So instead what I'll do is I'll just use you guys as my DR target, and now you worry about patching, you worry about hardware maintenance, you worry about BIOS updates, and I don't have to worry about that. So that's a pretty common pattern that we're seeing as well. And in fact, there's a company, Brinks, the security folks, the armored card guys, they actually have a session this week talking about that exact scenario. So if you're interested, I think is that tomorrow? Is that? Yeah, it's tomorrow. Yeah, Brinks was on stage with Sanjay yesterday, right? Or this morning. Yeah. So anyway, but yeah, that's definitely a common use case, something we support. There's a customer talking about that use case today. Okay, so I think that's my time. Thank you all very much. I'm happy to stand around the hallway afterwards. As you can tell, I'm pretty passionate about this subject. This is all I do, so I'll talk about it all day long, as long as you buy me beer. So thank you all very much, and hope you enjoy the rest of the event. Thank you.